Hi, my name is Sukhmeet Singh, and today I am going to show you here one of my project of digital electronics, which is on the topic digital clock, and we are performing that project on the software that is Quartus Prime, and we have this DE10 Lite FPGA board on which we we will see all the output results on the display of the E10 Lite board. So the digital clock project is totally basis on the our digital clock and the time. The time is shown digitally on a digital clock instead of an electromechanical clock that rotates. It counts seconds, minutes, and hours using display counters. Every 60 minutes is equal to 1 hour and every 60 seconds is equal to 1 minute. The clock has 24 hours to reset and start over. In this study, a timer and a digital clock are made using this FPGA board. So these functions are implemented by the counter and display modules. So HDL synthesis and analysis are made possible by the Quartus Prime, so which is utilized in the system overall development. Intel offers programmable logic device design software called Intel Quartus Prime. The tool was formerly known as Ultra Quartus Second and Ultra Quartus Prime before Ultra was acquired by Intel. With the help of Quartus Prime, developers can assemble their design, perform timing analysis, examine RTL diagrams, simulate how a design will respond to different stimuli, and configure the target device using a programmer. Quartus Prime include implementation for vector waveform modeling, visual editing of logic circuits, and hardware description in both Verilog and VHDL. So today we also rebuilt the program after I used the pin assignment to carry it out. Once the program was compiled and uploaded to the board, our digital clock will begin to function. So here I am opening a new project. 24-hour clock. So I had made a script of a program which we implement, and after implementation we will see that the digital clock will be running on the display of the board. So here the name of my project is clock underscore top. So here an internal clock signal updates the second, minute, and hour counters. That makes the counter module. Every counter ends with an internal clock signal that is generated and updated by the counter before it. A 7-segment common anode display, and this display is all that makes the display module. A changeover lets you choose between the display module and the digital clock and counter module. These modules carry out the required functionality on the board. So this is all the counters done, and now we are going to compile this program. So here we can see that program is progressing here. It is showing 1% here. So in this instance, like I'm showing you the board meanwhile. like in the default mode. We can see now there it is in default mode. I just connected it via USB to my laptop port, so it is in a default mode right now. So in this instance we used low cost Intel Max 10 FPGA board. So this is utilizing the highest capacity Max 10 FPGA. This board has an on-die analog to digital converter ADC and approximately 50K logic elements. It features an expansion counter, a 2x20 GP extension connection, an accelerometer, SD-RAM, a VGA output, and an onboard USB blaster. Before you style, prepare your paper. It is mostly employed in the development of FPGA designs. The board has many qualities make it suitable for use in a laboratory, the completion of diverse design projects, and the creation of digital system. So the specification of this device is it contains sensor which is known as G sensor, hardware content DE light development board, type A and type B USB cablers, accelerometer, 2x20 GP IO connector, 6-7 segment display you can see here, and 64 MB SD RAM which is inbuilt on the board. 64 MB SD RAM into 16 bits data bus. So if we check, our compilation is almost completed. Here you can see. So now it's time to compile this program to my board. So this is how we can compile it to the board. So in this programmer we can see, so our USB blaster is showing here. Make sure always here the setting should be USB blaster, and when we select this you can it is shown here like program configure. So if you tick this, then the program run by you is automatically configured on this. So after ticking this, let's start it. So start it. It is showing here like 100% successful. So now you can see the board. Here you can see the program is run here. This is the counter on for seconds: 15 seconds, 16 seconds, 17 seconds. So the digital clock started here, and when it is completed to 60, then the minutes counter will start. When minute counter ends with 60, then hour counter will start. The minute counter is updated when it reaches 60 by seconds counter, which is powered by the seconds generator count. After 60 minutes, the hour counter will begin to run. When the digital clock reaches 23 hours, 59 minutes and 59 seconds, the counting is restarted and is set to 00. Now you can see it 58, 59, 60 seconds, and after 60 seconds it gone to 1 minute. So similarly, after 60 minutes the hour counter will start. So this is all the normal running of digital clock. The second is, if you want to manually set the time or change the timer, then we have a process here. Like these are LED switches. If you switch on one of the LED, and now it changes to reset mode. So these two keys we can use 0 and 1 to change the value of these minute, seconds and hours. So this first key is used to, which is known as key 0. Key 0 is used to select the counter which you need to change the value for. So first we are changing hours. So hour Now key 1 is used to change the value of hour, like 2, 3, 4. If I set 4, now minute, if you want to choose minute, then again key 0, it go to minute, change the value of minutes. Now seconds, again key 0, change the value of seconds. When you feel that this is the actual value I want to reset my clock to, then switch it off again. Now clock will start from that value. This is how you can change the time in digital clock. So this is all about my digital electronics project about digital clock. I hope this will help you a lot. Thank you so much.